This is an example of a very typical problem that you would see on the STAAR test. The first thing you want to do when you see a table problem is this is a very typical table problem that you would see on the STAAR test. When you come to table problems, you want to look at your category titles. So we have on the left the total number of fruit snacks. It's important that you circle those because you're going to be looking for them later on in your answer choices. And then number of boxes. We want to identify our pattern before we look at our answer choices. And I can see that my numbers as I'm going from left to right are decreasing. So 48 to 3 is decreasing significantly. Now I might be subtracting. I could be subtracting 45, or I could be dividing. Now as I look down to my second number, 96, going to 6, I can see that the numbers along the right hand side are decreasing at a much slower rate than the numbers on the other side. So I'm going to go ahead and rule out subtraction for now and test division. So let's do 48, and I'm going to divide by 3 so I can see what the relationship is between those two numbers. So I can see that 48 divided by 16 is 3. Now I'm going to test this out. And for many students, division takes much longer than multiplication. So let's mix it up. If I think that the pattern going in this direction is division, then I know if I go in the other direction, the opposite direction, I'm going to be using the inverse relationship. And that means I would be multiplying. So why don't we test it out with 6 and 16. Let's do 16 times 6. And I get 96. So that means that I have found the correct relationship. Now I can go ahead and go down to the bottom and start testing out some of these answer choices. I'm looking for the correct pattern. A says the total number of fruit snacks, and that looks awfully familiar to me because that is one of the titles in the table. Plus 51. Okay, so the total number of fruit snacks plus 51 is, now is another word that means equals. Is the number of boxes. And you know what? This looks awfully familiar to us as well because this is our other category title. So in order to test these out, I'm going to go ahead and pick a set of numbers from this table and just plug them into each of these relationships. I suggest you always pick the second set in the table because oftentimes the first set will have another answer choice that will work for it. For instance, in this case, they might use a subtraction. They might say 48 minus 45 would be 43. And if you follow along later on, you'll see where that takes place. So we don't want to use the first set. Let's always try and use the second set. So for the total number of fruit snacks, I'm going to use 96 because that is in the total number of fruit snacks column. So 96 plus 51 is the number of boxes. And for the number of boxes, I'm going to use my number of boxes up here. And I have to use the number that goes with 96, which would be 6. Okay, clearly 96 plus 51 is not 6, so I can eliminate this answer choice. Let's go ahead and look at B. The total number of fruit snacks, and we're just going to use the same numbers. I'm going to use 96 again, times 18 is, which means equals, the number of boxes, and we are going to use 6 because that is, again, is the number that's paired with 96. Now, I clearly know 96 times 18, I can't have a product that is 6 that's much smaller than those, so that is not the correct answer. C, the total number of fruit snacks, let's use 96 again, minus 45 is, which means equals, the number of boxes. 6. 96 minus 45 is 51. So this is not the correct answer. Let's look at D. The total number of fruit snacks divided by 16 is the number of boxes. And we know from our work that we did up here that that is true. If 16 times 6 is 96, then 96 divided by 6 would be 16. So D is the correct answer. Which of the following statements is true about this pattern? So in this problem, we have a very different set of numbers to look at. We don't have a table. We have a list. We have list Y, and then there's a corresponding number in list Z that goes with each of those numbers. We can go ahead and just think of it like a table. Let's think of this as though it's a horizontal T-table. And if it helps you to draw a table in, then draw a table in. So as I go from numbers that are on the top down to the bottom, I can see they're increasing. So if they're increasing and we're only doing one-step problems, then I could either be multiplying or adding. It doesn't appear that I'm multiplying. And the reason I can say that is because when I look at 14 and 8/10, if I was to multiply that even by 2, I would have something close to 30. But down below I have something that's closer to 20. So it looks to me as though I'm adding. So I'm going to go ahead and take a set of numbers, and I always like to just work with the second pair, and I'm going to subtract, because if I subtract, I can see what the difference is, and I can see what's been added in this problem. So I found that there was a difference of 4 and 9/10, so I believe that they are going to be adding 4 and 9/10 in this problem. Now I need to make sure, so I'm going to check that with another pair of numbers. Let's go ahead and use these right here. So I'm going to take 14 and 8/10 and I'm going to add it to 4 and 9/10. And I'm going to see what I get. If I get 19 and 7/10, then I have the correct answer. And I do. So I have correctly found the pattern. The pattern is adding 4 and 9/10 going down. So now let's look for the statement that matches that. Now right off the bat, as I look at A, the numbers in list Y are 5 and 1/10 less than the numbers in list Z. I know that it's not going to be one of my answer choices with 5 and 1/10. It's going to be one of my two answer choices with 4 and 9/10. So without even doing any more work, I'm going to eliminate A and B. Now let's look at C and D, because sometimes they give us the backwards pattern. Sometimes they're asking, what is the pattern going from the bottom up? If I know from the top down I'm adding 4 and 9/10, then going in the opposite direction, I'm doing the opposite operation, the inverse operation. I would be subtracting. So I need to figure out which one they're talking about. The numbers in list Y, and to test this out, let's go ahead and use our second set of numbers. So list Y would be 17 and 2/10. That's the number that will represent list Y. Are 4 and 9/10 less than the numbers in list Z. So you have to really think about this. R is actually the word here that signals the equal sign. So 17 and 2/10, is that equal to the numbers in list Z minus 4 and 9/10? So we're going to use 22 and 1/10, and we're going to subtract 4 and 9/10. One thing that I've told my students is that when you see less than, typically the number before that and the number after that are going to trade places. And that's exactly what we see here. So this 4 9/10 went to the end. The number that we used to represent list Z went to the beginning. Now, is this a true statement? Yes. If I look back over at my work up here, if 22 1/10 minus 17 2/10 is 4 9/10, then this would be a fact in that fact family. It would be a related fact. Let's look at D. We believe our answer choice is C, but we need to make sure that D is not correct. The numbers in list Y, so we're going to use 17 2/10, are, that's our signal word that means equal sign, 4 9/10 more than, oh, that more than means I'm probably switching, and more, that tells me I'm going to be adding that, more than the numbers in list Z. And the number that we're going to use for list Z is our 22 1/10. So is that true? Well, no, clearly not. We can't have a smaller sum over here than the two numbers that are our add-ins. So we know that our correct answer is choice C. The important thing to remember when you get to these tricky table problems, finding your pattern is only half of your work. The other half of the work is in deciphering which one of these correctly identifies the relationship. Just take your time and you will pass through these types of problems very easily.